Okay, hi everyone, I'm Stephen Capasso. I'm going to solve problem 1 from homework 4. This problem is about mapping x into y. We're asked to find and draw the distribution fy sub y and the function fy sub y in terms of f sub x of x, fx of x, and function of x of x. We are given y is equal to g sub x, some various metrics and ranges, and if we plot this out, y is equal to g sub x, we get this here. There isn't much more to say about that. Let's just point out though that so for y is greater than or equal to minus 1, so yeah, y is greater than or equal to minus 1 and less than or equal to 2, right? That's the range of y, as we can see there. And also fy sub y is equal to 0 when y is less than minus 1, and it's equal to 2 when y is greater than 2. So that's that. Again, this week I chose to use this painter's easel and have everything pre-written to save some time, because many times I go over 5 minutes. All right, so getting right to the point here. There's some line items that evaluate and look at things over the ranges y greater than or equal to minus 1 and less than or equal to 2. I won't spend a lot of time on that, but I will get to some key line items that are going to be important for the plots later. The function of fy sub y is going to have this type of characteristics: 1 minus f sub x, 1 delta y plus 1 at y equals minus 1, and f sub x minus y over the range of y is greater than minus 1 to less than 0, and fx1 minus fx0 delta y, y equals 0, and fx0 delta y minus 1, y equals 1. 0 elsewhere. And the distribution fy sub y is going to be 0, y less than minus 1, and 1 minus f of x minus y, y greater than minus 1 and less than 0. And also it's going to be have an amplitude of 1 minus fx1 for y greater than or equal to 0 and less than 1, and it's going to be 2 for y is greater than or equal to 2. We'll see that plot. We'll see those plotted a little later. Now this is an entire integration that it's a whole mess. I'm not going to go into it, but it ends up into this result, and this has to do with the distribution fx of x, where it accumulates up to a value of 1, and just it's basically this 1 minus fx of y, and that's how that looks. And needless to say, the function of x has this kind of profile. Now the final results for distribution fy sub y is this, where we can see the various elements that compose this waveform. We have an amplitude of 1 minus fx of 1 for here, and 1 minus fx minus y, function minus y in this region right here, and the amplitude of 1 minus fx of 0 for here, and then finally fx of 0 here. And that's the distribution of f sub y sub y. This is a complex, this is a hard problem. Did my best to get it oriented the way I think it should be. Finally, the function of y sub y is broken out into these various line items. There's some delta functions. There's a delta function of 1 minus fx to 1 at minus 1, y is equal to minus 1. And then there's this fx minus y, this little partition here. And then another delta function that occurs, fx1 minus fx0 delta y. So that's the amplitude of that delta right there. And then finally, there's another delta function that occurs at y equals 2. and amplitude fx of 0. That's it.